Greetings, friends. Randall Nagy here, welcoming you out to the sixth edition of our built-in report. And no matter if your bacon is defined in terms of turkey, ham, or tofu, I think we can all get along, certainly when we're working with Python. And today we're going to be talking about how we can get along using both human representations as well as evaluatable, or Python's favorite way of looking at string representations. So we're going to be talking about the built-in str and rpr functions, and to help us navigate some very advanced concepts, we're going to also introduce the id function to help us track our changes. So if you don't know, when we use repr in Python, we are actually going to get a representational type, and repr is simply one of the two string formats that we can have. One will be evaluatable, or our Pythonic representational string, as opposed to str, which we'll be talking about later, which gives us, of course, our human preferred way of looking at objects. Of course, rather than requiring us to have both a string as well as a representational type, the difference between str and repr is simply our choice, and all built-ins will, of course, have a choice made for us. In this case, let's take a look at the representational type for my namesake as a list, and we'll see if we evaluated that string. We've gone fully round trip from creating our list to getting a representational type for that list to creating yet another instance of my last name string. And that's the idea of using eval. Jumping ahead of ourselves a bit, of course, by no coincidence, when we're looking at a collection type in Python, the default for str as well as eval produce the exact same results. Once again, underscoring the idea that using str or repr is simply an opportunity for us to provide differences between our human and our evaluatable forms of an object. And in Python, the dunder str and the dunder repr are the ways we can provide our own implementations as our need and inclinations dictate. Often referred to as member wrappers, in this context we see that both the help strings for dunder str and dunder repr tell us that we can use the built-in methods, as we have mentioned, allowing us to confidently move on to the next topic, which is ID, or finding the identifier for each one of our objects. As you might have expected, when we create a list, the ID function will allow us to find the identifier. And in our default version of Python, that's always a memory address for anything we create, and different instances of a list in this case, or any collection type, will always give us a different memory address or an identifier. So while in Python, or CPython as a help system talks about a memory's ID is the object's memory address, other implementations may or may not use the memory address, but of course, if they're tightly following to the Python standard, ID will always return a unique number amongst any objects that can exist simultaneously in our program, or between any equivalent instances as assigned to our variables. So str works pretty much as we see, where we would go ahead and get a string representation of any object by calling the dunder str, therefore giving us a tremendous amount of power, as I mentioned previously, to provide our own strings, from help strings to fully qualified reports, as we probably should demonstrate now. To return one string, when activated by str, will return what we expect from the dunder repr when we use the repr, and the other dunder, or in this case dunder str, when we convert our class into a string. Curiously, if you're relying upon using string so as to create several instances of a string or many other collection types, we should note that in order to save memory, Python does indeed cache things with alias instances so as to give a reference rather than creating a whole new copy. And of course, we're talking about the difference between creating a shallow and a deep copy, which is described pretty adequately on my books on Amazon as well as my training. And if you want to make sure not to have things cached, we have to use a del keyword so as to delete not only one instance, but of course both. But fortunately, when we're talking about collections, we're not going to be caching instances of each one of our collections, but each one of our strings will still be cached so as to more efficiently save memory, unlike we might expect. Moving back to our list definition, you may ask yourself what would happen, for example, if we deleted the first object in our array, and as you would expect, everything from A would disappear, whereas what was in B would still hold on to our reference, and garbage collection would only delete the memory for our capital N after all references to that instance were removed, or string caching is otherwise defeated. In short, whenever I want to make sure even one of my strings are different, I'll either delete the item altogether, or I can rely on our trusty evaluation routine so as to create a totally new instance and bypassing string caching as we see here. Of course, string encoding was one of the big changes when we left Python 2, or 2.6 and 2.7 behind, and moved on to Python 3. And while you may not think of it very often, when we get into more advanced operations like file input and output, or even sending data across the internet, which still relies on octets of 2 to the 8, encoding becomes incredibly important. It is a source of much confusion. So we'll be talking more about encoding types and techniques when we work with files and review other built-in opportunities. But as a help documentation notes, we only need to import sys before using the sys.getDefault encoding member function of the sys module. Our review questions for our 6th session include a classic one covered in my book of KA1009. The built-in ID function will either 1, compare object identities, 2, verify object content, 3, uniquely identify an object, or 4, identify the Python version. KA 2014, once again in my book. The purpose of the repr built-in function is to 1, reproduce 2 objects by combination, 2, return a clone instance of an object, 3, return a string for humans to view, 4, get a string to recreate an object, or 5, none of the above. KA 2042 is a new one, which asks us what is the difference between stir and repr, and is it either string objects use eval, or eval objects use stir, or repr is for humans, strings are always the same, or 5, none of the above. Another new intermediate question, KA 2043, object contents. A done to stir opportunity may represent 1, instance reporting, 2, object evaluation, 3, big data, 4, SQL databases, or 5, none of the above. And our final advanced question, a new one, KA 3043 string encoding. Question is how to determine platform stir encodings. Would we import either 1, 2, 3, 4, or 5? And while you might be intimidated by this one, if you take a close look at each, you'll see the answer is rather obvious. So, thanks for watching. And although I haven't mentioned it, when I say we have a new question or an old question, what I'm referring to is my books on Amazon, as well as the cards up on GitHub, as well as the books related there too. And if you're in a quandary for either one of the old or new questions, take heart. My books will be updated very soon. And until then, I'm indeed looking forward to seeing you in the professional software development world.